Good day and welcome to this lesson. In this lesson, we are going to study circle. And in studying circle, we are going to consider equation of a circle. We will determine the center and radius of a circle when its equation is given. We will also look at tangent to a circle, normal to a circle, intersection of a line and a circle, intersection of two circles, and that will lead us to looking at orthogonal circles. And then we will also look at loci. So what then is a circle? A circle is a locus of points equidistant from a fixed point. What that means is that there is a fixed point here. That point is called the center. And then there is another point moving. Consider my pointer here as the point moving. And as the point moves, it maintains an equal distance with the center of the circle. And the path that this point traces is the circle that we are talking about. Okay, so when we talk about a circle, it is a path a point traces as it moves in such a way that it maintains an equal distance with the fixed point, which we call the center. Now, the distance from the center to the point is what we call the radius. Okay. In looking at the equation of a circle, we will apply the Pythagoras theorem to determine the equation of any given circle. And so we will take a quick look at the Pythagoras theorem. The Pythagoras theorem is a theorem that talks about right angle triangle. So as you see this right angle triangle here, we have side AB, we have side BC, and we have side AC. Now if you look at it well, you will see that side AC is relatively longer than side AB and side BC. And then let's assume that the distance between AB is P and the distance between AC is R, and also the distance between BC is Q. Now Pythagoras theorem says that for a right angle triangle, if you take the two shorter sides, in this case side AB and side BC, and then you square each of them and sum them, the result you get will be equal to the longer side squared. So that is P squared plus Q squared will be equal to R squared. That is what the theorem says. Or if you want to use the side as the length AB squared plus the length BC squared is equal to the length AC squared. So this is the Pythagoras theorem. Don't make a mistake to say that P plus Q is equal to R. These are not equal. They are not equal. They are not equal unless they are squared. So if you don't square them, they will not be equal. And so this expression here or this equation here does not talk about the Pythagoras theorem. So you take note. We have a circle given with the center here. Now the center is shown clearer with the intersecting vertical and horizontal line here. Now if you look at the circle, well, you see that from the center to the circumference, the distance is 1 unit, and it is the same on this side. It is the same on this side also, and it's also the same side on it's the same on this side. This one we can describe it as a unit circle, and the radius, as you remember, is the distance between the center and the circumference. So from the center to the circumference, this line becomes a radius. This line is also a radius. This line is also a radius, and this line is also a radius. And if I draw any other line from the center to the circumference, it is also a radius. So we take notes of that. Now, if I put a point here, a point xy here, any point on a circle satisfies the equation of that circle. So if I put a point here and I draw a green straight line from the point to the center, that point, that line also becomes the equation. Sorry, that line also becomes the radius. You remember that. Then I draw a vertical line from the point to the x-axis. Then I also draw a horizontal line from the center to meet the vertical line that has been drawn. This gives a green outline here. That is a right angle triangle. Now, if I want the distance from the center to the point where the green lines meet, because we have the point xy here, what it means is that we can trace this length to y value here, and then down here we have x value here. They give us the point xy that we have. Now, if I want to know the distance between the center and y, I will need to know the value of y and then subtract. So from here to here, I'll subtract the value here from y. And in this case, because it's a center, the value here is 0. And so the distance here will become y minus 0. And that is what we have on this side, the green line, the vertical line here, y minus 0. Then for the horizontal side, we will also have the value here, and then we will subtract the value here from it, and that will also give us x minus 0. So if I decide to tease out the right angle, what I have here now is r, and I have y minus 0, and I have x minus 0. So these are the lengths of the sides of the right angle triangle here. So if you are to apply the Pythagoras theorem to this diagram, then the longer side, which is r, when we square it, it will be equal to the sum of the squares of the other two sides. So that we will have x minus 0 when we square, and then add it to the square of the other shorter side, y minus 0. It will be equal to the longer side squared, which is r squared. So this is how we apply the Pythagoras theorem to get the equation of a circle. So here I will now expand my brackets. S minus 0 is s, and s squared will be s squared. And then the same happens here, y squared, and it's equal to r squared. So I can simplify this as s squared plus y squared minus r squared is equal to 0. Now this is the equation of a circle when the center is at the origin. That is when the center is 0, 0. And for this specific circle, because we know the value of r, which happens to be 1, the equation of this particular circle will be s squared plus y squared minus 1 squared, which is 1, is equal to 0. I hope this is understandable. Now we consider a circle whose center is not at the origin. So if you look at the diagram, the graph here, the origin is at this point and the center of the circle is found here. So the center of the circle is not at the origin. So we assume that the center of the circle is the point AB. And then as you can see, I have a point on the circle XY here and a straight line from the point to the center. That is my radius, if you remember. So here I have my radius here. Now the distance from the center to the value y here, we said we will subtract the value of y. We will subtract the y value at the center from the y value here, and that will give us y minus b, and that is the length of this vertical side of the right angle triangle. So we have y minus b here, and then for the horizontal side we will have s minus e. Now if I redraw the right angle triangle here on this side, I'll have it as this. So I have here as s minus e. Let me use a different color. X minus a, and then I'll have here as y minus b, and then I have here as r. So we are going to apply the Pythagoras theorem to this right angle triangle, and that will be x minus a squared plus y minus b squared, and this will be equal to r squared. Now we will have to simplify. That will give us s squared minus 2ax plus a squared plus y squared minus 2by plus b squared is equal to r squared. So we will have it as s squared plus y squared minus 2ax minus 2by plus a squared plus b squared is equal to r squared. So I'll also bring the r to this side of the equation. That gives me s squared plus y squared minus 2ax minus 2by plus a squared plus b squared minus r squared is equal to 0. That will be the equation of a circle. Now we have the equation of the circle as s squared plus y squared minus 2ax minus 2by plus a squared plus b squared minus r squared is equal to 0. Now we want to make things easier for us ourselves. So we are going to represents, so we let G represents minus A and F represents minus B. So with this, we are going to now have the equation as S squared plus Y squared plus 2gx plus 2fy. So now, since J is representing A and B, when we square a negative J, it will still be a positive number. So here we have J squared plus F squared minus R squared is equal to 0. Okay, now there is another thing we should look at. Now, if we take a circle, so let's say this is the Cartesian plane. A circle is made up of points which are given in the values of x, y. So if you have a point here, its value will be given as x, y. What that means is that in the equation of a circle, our variables are x and y. So this is our variable, this is a variable, this one is also a variable, and then this one is a variable. All the other variables you see there are constants that we will have in the equation of a circle. And so the only variables we have are x and y. What that means is that the whole of j squared plus f squared minus r squared are constants. If that is the case, we would try and make the expression simple. And to make it simple, we will put them together into one value as a constant. So we will let C represent all the constants together. That is j squared plus f squared minus r squared. And that's the equation of the circle now becomes s squared plus y squared plus 2gx plus 2fy plus c is equal to 0. So now j squared plus f squared minus r squared have all become one thing, c. And this gives us the equation of a circle. This is the general formula of the equation of a circle. Or we can also quote it as s minus a all squared plus y minus b all squared is equal to r squared. This is also acceptable as the equation of a circle. After all, we simplified this to get the longer one that we have there. Okay. Now, given the equation s squared plus y squared plus 2gx plus 2fy plus c equals 0, we remember that c represents j squared plus f squared minus r squared. And so if we know the value of c, we can determine the value of f, and then we can also determine the value of j. Then we can, based on these values, determine the radius of the circle. That is, from c is equal to j squared plus f squared minus r squared, we make r the subject as r squared is equal to j squared plus f squared minus c. And when we square both sides, because it is length, we will have the positive root of j squared plus f squared minus c. So this is one way of finding the radius of a circle. Okay, so let's take note of that. The next thing is to talk about the characteristics of the equation of a circle. Characteristics of the equation of a circle. Now, when you take the equation of a circle, as we have already stated, the variables we have are x and y. 2j, 2f are constants, and c is also a constant. Now, the first thing we need to note is that for every equation of a circle, the highest power of our variables will be power 2. So the highest will be s squared and then y squared. So we will have the highest power as s squared and then y squared here. That is, we can have s to the power 2, and then we can have y to the power 2. Now let's also come to the next one, which is about the coefficients of s squared and y squared. So let's say the first one. The second one is that for every equation of a circle, the coefficients of s squared and y squared are expected to be the same. For every equation of a circle, the coefficients of s squared and y squared are expected to be the same. So if we have s squared here, we have y squared here, then we expect that if the coefficients of s squared is m, that of y squared will also be m. If the coefficients of s is p, then that of y squared will also be p. So that is what we mean. And the coefficients of s squared and y squared cannot both be 0. So p here cannot be 0. If it becomes 0, then we will lose the s squared and the y squared values. And that's the remaining equation will be 2js plus 2fy plus c is equal to 0. And this, as you can see, is a linear equation, not equation of a circle. So once the coefficients of xy, s squared, y squared becomes 0, then we lose the equation of a circle to equation of a line. So that is what it means. And the third thing we should note is that for the terms in the equation of a circle, there won't be any term where x and y are multiplying. So if we look at the equation, you see that s squared, it has only x variable in it. Then y squared, it has only y variable in it. Now when you look at the third term, 2j's, you should remember that 2j is a constant, is a coefficient. The only variable is x. And then when you take the fourth term, the only variable is y. So we don't have any term where x, y are multiplying. So that is the next thing to note. So for the equation of a circle, we will not have anything like sy. we will also not have anything like x squared y or x y squared. We don't have them in the equation of a circle. So let's take note. Now we determine the center and radius of a circle when the equation of the circle is given. Okay, so now we take our first example. We are to find the center and radius of a circle x squared plus y squared plus x plus 4y minus 2 is equal to 0. Okay, so let's see how we solve this. Now, one way of determining the center and the radius of the equation of a circle will be to compare the equation given to the general form of a circle, the general equation. So we have the given equation as x squared plus y squared plus x plus 4y minus 2 is equal to 0. Then the general form of the equation is given as x squared plus y squared plus 2gx plus 2fy plus c is equal to 0. Now comparing the two, we see that 2g is equal to 1. And so we can say g is equal to 1 over 2. If we remember, we used g to represent negative a. So it means that negative a is equal to 1 over 2. And so a will be equal to negative 1 over 2. And then we will have 2f is also equal to 4. So our f will become 2. And we remember that we used f to represent negative b. So negative b is equal to 2. And that our b will be equal to negative 2. Now, if you remember once again, A and B represent the center of the circle. And so, for the circle given, our center will be minus 1 over 2 and then negative 2 as we try to find. Then, to get the radius, we have C is equal to g squared plus f squared minus r squared. So we can determine r as square root of, that is the positive square root of g squared plus f squared minus c. Okay, so now we know g, we know c from the equation. When we compare the general equation, we see that c is negative 2. So our r will be square root of g squared, which is 1 over 2 squared, plus f squared, which is 2 squared, and then minus c. And the c is already negative, so minus negative 2. Okay, so we simplify that and we will have 1 over 4 plus 4 plus 2. And this gives us 1 plus 16 plus 8 over 4, which is equal to square root of 25 over 4. And this is 5 over 2 all squared, which the square will cancel the square root, and then our r will be 5 over 2. So the radius is 5 over 2. Now we are going to use another method to solve the same question, and that is the method of completing the squares. Okay, so we have our equation. I will rewrite the equation as s squared plus x plus y squared plus 4y is equal to 2. I'm using the method of completing the squares. So I take the s side and I'll also take the y side. Okay, so taking the s side, I will have s squared plus x. Then I'll take the coefficients of x, divide it by 2, and square the result. So the coefficients here is 1. When I divide by 2, the coefficient is 1. When I divide by 2, I get 1 over 2. When I square the result, it's what you see. So now, when I do this, I will add it to both sides of the equation. So I have plus 1 over 2 squared. And as I said, I will add it to both sides of the equation. 2 plus 1 over 2 squared. Then I also take the y side. I'll have s squared plus x plus 1 over 2 squared plus y squared plus 4y. Now I take the coefficients of y, which is 4, divide by 2 and square the result. So as we see, when I divide 4 by 2, I'll get 2. So when I square the result, it will be 2 to the power 2. So I add it to both sides of the equation. Like this. And that is it. Now, let's take a look at something here. If you are not very familiar with the method of completing the squares already. Now, let's look at the first 3 terms here. I will take the x, that is the base value of the s squared. I will take just the base value. And then when I come to the constant here, I will also take the base value. So I'm doing the illustration on this side. I'll take the base value, which is x, and then I'll take the base value, which is 1 over 2, and add them. Then I'll square them together like this. Now let's see, when we expand this, we use the perfect square method to expand this. Let's see what the result will be. So s squared plus x times 1 over 2 times 2. That will give us x. And then we also square the constants. That will give us 1 over 2 squared. Now, when you look at what we just got, is it the same as what we have here? Is it the same as what we have here that I have put the rectangle on it? You see that it is the same. What that means is that we can express these 3 terms as 2 terms like this one. So we will rewrite it as s plus 1 over 2 squared, and that takes care of the three terms. Okay, then we are going to add it to a similar situation with the y. So the y2, when I take y and then I add it to 2 and I square both of them, the result will be y squared plus 2 times y times 2. That will be 4y, and then plus 2 squared. So you see that it's also the same as the three terms there that we see, these three terms. So this can also be expressed as this. Okay, I hope you are following. You can always replay the video to look at it again. So I'm now expressing the y in terms of the power y plus 2 squared, and this is equal to 2 plus 1 over 2 squared will be 1 over 4, and then 2 squared here will also be 4. Okay, so we are going to continue. Let me quickly clean what I did here. Then we have x plus 1 over 2 squared plus y plus 2 squared is equal to, so here when I put them together, I'm going to get 25 over 4. Now, I want us to look at what we have here. We have expressed the equation of a circle in the form s minus a squared plus y minus b squared is equal to r squared. That is what we have done. So if you look at what we have, minus a here is representing 1 over 2 from the circle. So minus a is 1 over 2. That means a is minus 1 over 2. And then minus b is also representing 2. And that b is equal to negative 2, which gives us the center minus 1 over 2 and then minus 2. Then when you compare r squared, so r squared 2, we see it as 25 over 4. So to get r is the positive square root of what we have here, 25 over 4. And that r will be equal to 5 over 2. So this is how we find the center and the radius of a circle. This is another method. This one is method of completing the squares. Now let's take our second example. Find the center and radius of a circle 4x squared plus 4y squared minus 12x plus minus 8y plus 9 is equal to 0. So our solution. Our general formula is s squared plus y squared plus 2gx plus 2fy plus c is equal to 0. Now looking at the equation of the circle given, we must make some adjustments before we can compare with the general formula, because looking at the general formula, the coefficients of s squared will be 1, but looking at our specific formula, the coefficients of s squared is 4, and so we need to simplify that to look exactly like the general formula before we can do the comparison. So 4x squared plus 4y squared minus 12x minus 8y plus 9 equals 0. What we are going to do is we are going to divide through by 4. And when we do that, we get x squared plus y squared minus 3x minus 2y plus 9 over 4 is equal to 0. So this time we can do our comparison. So if I will do my comparison right, I'll say C is equal to 9 over 4. 2J is equal to negative 3. And that means J is equal to negative 3 over 2. And we know J is negative A. So our A will be equal to negative of negative 3 over 2. That is, A will be equal to positive 3 over 2. Then F. So 2F will also be equal to negative 2. F will be equal to negative 1. And as we remember, F is equal to negative B. So B will be equal to negative 1. So B here will be equal to positive 1. So with this, the center of the circle will be 3 over 2 and 1. And once we have the center, we can now determine the radius. So we determine the radius as r is equal to square root of, remember, it's J squared plus F squared minus C. So our r here will be equal to square root of, so this will be the, so r will be equal to square root of, when you square negative 3 over 2, that will give us 9 over 4, plus square of 1 will be 1 minus 9 over 4. Okay, so now you can see that 9 over 4 and 9 over 4 will cancel themselves out, giving us r is equal to root 1, which means r is equal to 1. Therefore, for the equation given, the center is 3 over 2, 1, and the radius is 1 unit. So that is there. And then if we are going to use the second method, that is the method of completing the squares, we also keep the simplification s squared plus y squared minus 3x minus 2y plus 9 over 4 is equal to 0. So we will rearrange them as s squared minus 3x plus y squared minus 2y is equal to 9 over 4. So I'll have s squared minus 3x. Now if I take the coefficients of s and divide by 2, that will be negative 3 over 2, and I square the result, that will be negative 3 over 2 squared here. Remember, when you square the result, do not open the brackets. Let it remain as a base and its exponent. Okay, then I take the y side, so plus y squared minus 2y. Then when I take the coefficients of y, divide by 2, I'll get negative 1 and I'll square it. So plus negative 1 squared. And everything here is equal to 9 over 4. And then I'm adding minus 3 over 2 squared. And then I will also add negative 1 squared. Okay. So as we looked at before, we have a correction to make. Now, when from here, when we moved 9 over 4 to the other side of the equation, it should have become negative. So let's correct that. So here we have negative 9 over 4. So what we have here is negative 9 over 4. Okay, thank you for your understanding. So now we take the first three terms and then express it as s minus 3 over 2 all squared. Then we will add it to y minus 1 all squared, and it will be equal to negative 9 over 4 plus 9 over 4 plus 1. And that gives us x minus 3 over 2 all squared plus y minus 1 squared is equal to 1. And this one, comparing with the general formula, we see that a will be equal to 3 over 2. B will be equal to 1. And then our r squared is also equal to 1. So the center of the circle is 3 over 2, 1. And then the radius is 1 unit. Okay. Find the center and radius of the circle x squared plus y squared minus 2x plus 4y minus 3 is equal to 0. Solution. So comparing this with the general formula, we have our 2g to be equal to negative 2. So g is negative 1 and a will be equal to positive 1. Then we have 2f to be equal to 4, f will be equal to 2, and then our b will be equal to negative 2. The center of the circle is 1, negative 2. Then the radius. So r squared, no, r is equal to root of negative 1 squared plus 2 squared minus negative 3. That is our c. And that's, we have 1 plus 4 plus 3. That will be root of 8. So the radius becomes 2 root 2 units. So that is the radius of the circle as required. So if you are also using the second method, then we are going to rearrange as s squared minus 2x plus y squared plus 4y minus 3. Okay, so that's equal to positive 3. So we take the coefficients of x, divide by 2 and square the result. So that will s squared minus 2x plus minus 1 squared plus y squared plus 4y plus 2 squared. and that is equal to 3 plus minus 1 squared plus 2 squared. So we have x minus 1 all squared plus y plus 2 all squared is equal to 3 plus 1 plus 4. S minus 1 squared y plus 2 squared is equal to 8. So now when we compare this with the general formula, that is the formula s minus a squared plus y minus b squared equal to r squared. When we do this comparison, we see that a is equal to 1, b is equal to negative 2. Therefore, it gives us the center 1, negative 2. And then we also see the radius squared as 8. So when you find the square root of both sides, you get the radius as root 8. And that is 2 root 2. So that is this. Find the equation of the diameter which passes through the point 1, negative 2, a point on the circle s squared plus y squared minus 6s equals 0. Solution. Now, the diameter is a straight line, and the straight line passes through the points 1, negative 2, and the center of the circle. And so we have to determine the center of the circle. Looking at the equation of the circle, our 2g will be equal to negative 6. So g will be equal to negative 3 and a will be equal to positive 3. 2f is equal to 0. That means f is 0 and b is 0. So the center of the circle is the point 3, 0. So the line passes through the points 1, negative 2, and 3, 0. So I can determine the gradient of the diameter as, if I label it m, then m is equal to 0 minus negative 2 divided by 3 minus 1. And that will give me 2 over 2, which is equal to 1. So the gradient of the line is 1. And it passes through the points 1, negative 2. Therefore, the equation of the line will be given as y minus negative 2 is equal to x minus 1. That is multiplying by the gradient 1. So y plus 2 is equal to x minus 1. Thus, the equation of the diameter can be given as y minus x plus 3 equal to 0. Okay. Finding the equation of a circle when the radius and the center of the circle are given. Okay, so this time around, we have been given the radius and the center, and we are rather supposed to find the equation of the circle. So what we do is we go back to the general formula. So let's write our solution. We'll go back to the general formula, which is s squared plus y squared plus 2gx plus 2fy plus c is equal to 0. Now we remember that the center of a circle is given as AB. And we also remember that G is equal to negative A. That means that A is equal to negative G. And then F is also equal to negative B, which also means that B is equal to negative F. So when we are given the center, we will be able to convert them into G and F. Okay, and the radius of the circle is also given, and we remember that R squared is equal to G squared plus F squared minus C. And so with the radius known, we can also determine our C as C is equal to G squared plus F squared minus R squared. And so we will go ahead and look at some examples. Example 1. Find the equation of a circle which passes through the points negative 2, 1 and has center with coordinates 2, 4. Okay, so let's go through it. Solution. Now, once we have a point on the circle and the center, we can substitute each of them into the equation, into the general equation. So we have x squared plus y squared plus 2gx plus 2fy plus c is equal to 0. So if we decide to substitute the center first, noting that j is negative a and then f is negative b, we will have x squared plus y squared plus 2 times negative 2x plus 2 times negative 4y plus c is equal to 0. So we simplify and get x squared plus y squared minus 4x minus 8y plus c is equal to 0. This is the equation of the circle. However, we need to find the value of c. Now, once the point negative 2, 1 is a point on the circle, it means the point satisfies the equation. And so we will substitute the point into the equation, and that will help us to determine the value of c. So let's do that. So in place of s, we put negative 2. In place of y, we put 1. So negative 2 squared is 4 plus 1 squared is 1 minus 4 times negative 2 minus 8 times 1 plus c is equal to 0. So we have 5 plus 8 minus 8 plus c is equal to 0. So if 8 cancels 8, our c will be equal to negative 5. Now once c is obtained, the equation of the circle becomes x squared plus y squared minus 4x minus 8y minus 5 is equal to 0. Now this is one way of finding the equation. There is another way. Another way is to determine the radius. And so if we want to find the radius, is the distance between the 2 points, the center and a point on the circle. So our radius squared will be equal to 2 minus negative 2, which becomes plus 2 squared, plus 4 minus 1 also squared. So our radius here becomes 4 squared plus 3 squared. 4 is 16. 3 is 9. So our radius squared will become 25. Now from here we can also find the equation by using the first principle, that is s minus the center squared, and then y also minus the center squared is equal to r squared. Then if we simplify, we have s squared minus 4x plus 4 plus y squared minus 8y plus 16 is equal to r squared, which is 25. So s squared here plus y squared here, then minus 4x minus 8y. I have 4 here and I have 16. When I add them, I'll get 20. So plus 20 is equal to 25. Now I will rearrange them as s squared plus y squared minus 4x minus 8y. So 20 minus 25 will give me negative 5 is equal to 0. And this is another way of solving it. Or if you like, when you get the value of r squared as we obtained as 25, you can go ahead and find the value of c. And we know c is equal to j squared plus x squared minus r squared. So that gives me 2 squared, which is 4, plus 4 squared, which is 16, minus r squared, which is 25. So this one, 20 minus 25 is negative 5. That's the value of c. And once you have the center, once you have the center, a is equal to 2. That means j is equal to negative 2. And then b is equal to 4. That means f is equal to negative 4. And then you also have your c as equal to negative 5. When you substitute, you get s squared plus y squared plus 2 times negative 2x plus 2 times negative 4y minus 5 is equal to 0. And so when you simplify, you are going to get s squared plus y squared minus 4x minus 8y minus 5 is equal to 0. So this is how we find the equation of a circle when the center and a point on the circle is given. Example 2. Find the equation of a circle which passes through the points 1, 3 and has center with coordinates negative 6, 5. Okay, solution. Now we have the general form of the equation as s squared plus y squared plus 2gx plus 2fy plus c equal to 0. Now our central value will be g and f. Those are the central values. So in place of g and f, we are going to put the coordinates of the center there. And so that we'll get s squared plus y squared plus 2. Now we note that j is negative a. And so negative of negative 6 will become positive 6. And then we also note that f is negative b. And so 5 will become negative 5. So we have it like this, plus c is equal to 0. So we have s squared plus y squared plus 12x minus 10y plus c is equal to 0. That becomes the equation of the circle. However, we need to find the constant c. Knowing that the point 1, 3 is on the circle, it means that it satisfies the equation. And so we substitute the point 1, 3 into the equation, and that will help us to get the value of C. So 1 squared will be 1, plus 3 squared will be 9, plus 12 times 1 will be 12. Okay, let me do the substitution properly. So we have 1 squared plus 3 squared plus 12 times 1 minus 10 times 3 plus C is equal to 0. So we have 1 plus 9 plus 12 minus 30 plus C is equal to 0. So we have this as 22 minus 30, which will be negative 8, plus C is equal to 0. And so C is equal to 8. That means the equation of the circle will be s squared plus y squared plus 12x minus 10y plus 8 is equal to 0. That is the equation of the circle. If you want to use another method, you can find the value of r squared. And so the alternative method, we find the value of r squared, which will be the center, a point at the center, and any other point on the circumference. So we can say uh, minus 6 minus 1 squared plus 5 minus 3 squared, and that will give us negative 7 squared will be positive 49 plus 2 squared, which will be 4, and my r squared will be 53. So taking the center, I'll have s minus negative 6, which becomes plus 6 squared, plus y minus 5 squared is equal to r squared. And here our r squared has been obtained as 53. So we open the brackets. We have s squared plus 12x plus 36 plus y squared minus 10y plus 25 is equal to 53. So if I group, I'll have s squared plus y squared plus 12x minus 10y then 25 plus 36 will be 61. 61 if I, okay, so plus 61 is equal to 53. So if I bring the 53 to this side, then I'll have 61 minus 53, which will be 8. So I have s squared plus y squared plus 12x minus 10y plus 8 is equal to 0. And that is the equation as required. Example 3. Find the equation of the circle which passes through the point negative 2, negative 6 and has center with coordinates negative 5, 1. Solution. Now the general form of the equation of a circle is given as x squared plus y squared plus 2gx plus 2fy plus c is equal to 0. Let's remember that j is equal to negative a. And so if we have a as negative 5, then it means j will be equal to 5. Then f is equal to negative b. So if we have b as 1, then f will become negative 1. So we are substituting the values of j and f into the equation. That gives us s squared plus y squared plus 2 times 5x plus 2 times negative 1y plus c is equal to 0. So that's the s squared plus y squared plus 10x minus 2y plus c is equal to 0. Now, I also know that the point negative 2, negative 6 is a point on the circle. That means the points satisfy the equation of the circle. So I'm going to substitute the points into the equation of the circle, and I'll be able to determine the value of c. So I have negative 2 squared plus negative 6 squared plus 10 times negative 2 minus 2 minus 2 times negative 6 plus c is equal to 0. That gives me 4 plus 36 minus 20 plus 12 plus c is equal to 0. So 40 minus 20, which is 20, plus 12, 32. 32 plus c is equal to 0. So c is equal to minus 32. Now substituting the c into the equation, I get s squared plus y squared plus 10x minus 2y minus 32 is equal to 0 as the equation of the circle. Equation of a circle when 3 points on the circle are given. So if 3 points, let's say point A, point B, and point C are given as points on the circle, the first thing I would want you to remember is that any point that is on a circle satisfies the equation of that circle. And so we are going to substitute each point into the general formula of the equation of a circle to obtain 3 equations in 3 variables. Okay, and the variables will be J, F, and C. Now, when we obtain the 3 equations, we will have to solve the equations simultaneously. So we solve them simultaneously. Once we do that, we will obtain the values of J, F, and C. And when we substitute these 3 values into the general formula of an equation, we will get the equation of our specific circle given. So that will be our first method. Now the second method, given 3 points on a circle, we are going to join the points to form a triangle. Draw lines to join the points to form a triangle. Now when we draw a triangle, I would like to take you back to JHS. Now, in JHS, we did geometric construction, and when we draw a triangle, at times we are required to draw a circle around the triangle to touch each of the vertices of the triangle. And what we normally do is we bisect at least two sides of the triangle. And where the two bisectors meet will be the center of the circle that we seek to draw. So for instance, in the diagram drawn, we can bisect side AB like this. We can bisect side AC like this. And our center will be the point of intersection of these two bisectors as shown here, like this. Then we take the center and any of the 3 points, the distance between the center and any of the 3 points as our radius. Then we draw a circle round the triangle. So that is what we were doing in JHS. This is the same idea we are going to employ in our second method. Unfortunately, we are not using compass and a ruler. So what we will do is that because the bisector is dividing the line into two equal halves, it means that the bisector will pass through the middle of the line. So we find the midpoint of a side. Then when we find the midpoint of a side, we also find the gradient of that same side. Now, when you find the gradient of that same side, assuming the gradient is m, this gradient will guide you to find the gradient of a line that is perpendicular to the side you are working with. And so because it is perpendicular, the gradient will be negative inverse of the side gradient you determined, and that will be negative 1 over m. Okay, so the next thing is for you to determine the equation of the perpendicular bisector. So you find the equation of the perpendicular bisector. Of the side you are working with. So when you do that, you label that equation as equation 1. Then you are going to repeat the same process on another side and then label that equation as equation 2. Once you get the two perpendicular bisectors, you are going to solve them simultaneously. You solve them simultaneously to obtain the center, that is their point of intersection, which serve as the center of the circle. And once you get the center of the circle, and then any of the 3 points on the circle, any of them, you can determine the radius and hence the equation of the circle. I hope this is understandable. Example 1. Find the equation of a circle passing through the points 3, 4, 0, 5, and 4, negative 3. Okay, so solution. Now let's employ the first method. So we have the general equation as s squared plus y squared plus 2gx plus 2fy plus c is equal to 0. Now if I am substituting the points 3, 4, so 3 squared will be 9, 4 squared will be 16, 2 times 3 times g will be 6g, and then I'll have 8f plus c is equal to 0. So I have 6g plus 8f plus c is equal to negative 25. That will be my equation 1. Then I'm also going to substitute the point 0, 5. So when I put 0 in place of x, x will vanish. So y squared will be 25 plus 10f plus c is also equal to 0. And that I'll have 10f plus c is equal to minus 25, which is also going to be my equation 2. Then I also substitute the third point, 4, negative 3. So 4 squared will be 16 plus negative 3 squared will be 9. 2 times 4 will be 8j, and then 2 times 3 will be minus 6f plus c is also equal to 0. I have 8j minus 6f plus c is equal to minus 25. That becomes my equation 3. Now I have these 3 equations and I'm going to solve them simultaneously. So I'm going to subtract equation 2 from equation 1. So equation 1 minus equation 2, I take the equation 1 has j, equation 2 doesn't have j, so 6j minus 0 will be 6j. Then 8f minus 10f will be negative 2f. C minus c will be 0, and then negative 25 minus negative 25 will also be 0. So this one, if I divide through, I'll get 3j minus f is equal to 0. And that I will label it as my equation 4. Then I will also subtract equation 2 from equation 3. So equation 3 minus equation 2. And that's also 8j minus, so that one, equation 2 still doesn't have a j factor. So equation 3, so here will become 8j, then 6f minus 10f will be minus 16f. C minus c will be 0, and then minus 25 minus 25 will also be 0. And so this one too, j minus 2f is equal to 0. That's my equation 5. Okay, so now I'm going to solve equation 5 and equation 4. So I'm going to multiply equation 4 by negative 2. And then I'll add the result to, so equation 4 multiplied by negative 2. And then I'm going to add the result to equation 5. Okay, so that will give me, the first thing is to do the multiplication. Equation 4 times negative 2 will be minus 6j plus 2f is equal to 0. And then I'm now adding it to equation 5. So that's negative 6j plus j will be 5j. And then f will go away, is equal to 0. My j will be equal to 0. Okay, so I'm going to substitute j into equation 5. So j minus 2f equals 0. If j is 0, then I'm going to have 2f is equal to 0. And my f will also be equal to 0. Now, if I substitute f into equation 2, I'll have 10f plus c is equal to minus 25. So if f is 0, then c is equal to minus 25. Okay, so now I have j 0, I have f 0, and I have c to be negative 25. Therefore, when I substitute into the general formula, I'll have s squared plus y squared. Now, when I put 0 in place of j, the s component will be gone. When I put 0 in place of f, the y component will also be gone. And then it will be left with the c, which is minus 25 equals 0. So this is the equation of the circle with the 3 points on it as given. Okay, now we are going to apply the second method. We have our point as 3, 4. Let's say that is A. Then we have 0, 5. Okay, let's label that as B. And then the last one, C, which is 4 minus 3. Okay, so we are going to assume that lines joining these points will make a triangle in the circle. So let's take the side AB. So we take the side AB, we are going to find a midpoint. And that will be 3 plus 0 divided by 2, which is 3 over 2. And then 4 plus 5 divided by 2, which is 9 over 2. This will be the midpoint of the line AB. Now the gradient. So the gradient is changing y. So we say 5 minus 4 divided by 0 minus 3. And this one will be 1 over negative 3. So negative 1 over 3. That is the gradient. So a line perpendicular to this one, perpendicular to AB, will have a gradient of positive 3. So that is our line. And that line is also passing through the midpoint. That is perpendicular bisector. And so its equation will be given as y minus 9 over 2 is equal to 3 times x minus 3 over 2. So y minus 9 over 2 is equal to 3x minus 9 over 2. So if I transpose y is equal to 3x, 9 over 2 plus negative 9 over 2 will become 0. So this will be the equation of the perpendicular bisector of AB. That's our equation 1. Then we take another side, let's say side AC. So we take AC, we find the midpoint of AC, and that will be 3 plus 4, which is 7 over 2. And then 4 plus negative 3, that will be 1 over 2. Okay. Now we also find the gradient. And the gradient will be 4 minus negative 3, which will be 4 plus 3, divided by 3 minus 4. So that will give us 7 over negative 1, so which is negative 7. And a line perpendicular to AB, AC will have a gradient of positive 1 over 7. So that line also passes through the midpoint, and so the equation will be y minus 1 over 2 is equal to 1 over 7 multiplying x minus 2 over s minus 7 over 2. So y minus 1 over 2 equal to 1 over 7x. Now 7 will cancel out 7, giving us minus 1 over 2. So if I group them, then I'm going to get y is equal to 1 over 7x, then negative half plus half will give us 0. So that also becomes the equation 2. Now I have equations 1 and equations 2. These two will give me the center of the circle when I solve simultaneously. Okay, so equation 1 and equation 2. So if y is equal to 3x for equation 1, then it means that if I put y into equation 2, I'm going to get 3x is equal to 1 over 7x. So 3x minus 1 over 7x is equal to 0. I factorize x out. 3 minus 1 over 7 equals 0. Divide through by the coefficients of s. S is equal to 0. So that is the value of x. Then y is equal to 3x. So in place of x, I'll get y is equal to 3 times 0. And so y is also equal to 0. That means the center of the circle is 0, 0. Okay. So with the center of the circle 0, 0, and any of the points given, so let's choose the point, let's say 3, 4. If we choose the point 3, 4 and the center, we can find our radius. Or we can even substitute straight away to find a value of c. So if I want to substitute straight away, I'll get s squared. So I'm substituting the center first. S squared plus y squared. The g components will be 0. The f components will be 0. So plus c is equal to 0. Then now I'm going to substitute the points. So I'm substituting the point 3, 4. So 3 squared will be 9. And then 4 squared will be 16 plus c is equal to 0. And this one is 25 plus c is equal to 0. So my c will be equal to negative 25. Now when I substitute into the equation, it means the equation is s squared plus y squared minus 25 is equal to 0. And this is the same value we also got when we use the first method as required by the question. Find the equation of a circle passing through the points A, B, and C as shown. Solution. So we are going to try to use the method where we substitute each point into the general formula. So the general formula is x squared plus y squared plus 2gx plus 2fy plus c is equal to 0. So when we take the first point, our point negative 5, 2, we are going to substitute into the general formula. And so s squared will be negative 5 squared, which is 25. Y squared will be 4. And we will have 2 times negative 5 times g plus 2 times 2 times f plus c is equal to 0. So we have 29 minus 10g plus 4f plus c is equal to 0. So we can simplify as minus 10g plus 4f plus c is equal to minus 29. And we will label that as our equation 1. Then we also substitute the points negative 3, negative 4. So negative 3 squared will give us 9, negative 4 squared will give us 16, plus 2 times negative 3g plus 2 times negative 4f plus c is equal to 0. So we have 25 minus 6g minus 8f plus c is equal to 0. I can also rewrite this as 6g plus 8f minus c is equal to 25. And that will be my equation 2. Then I take the third point, which is 1, 8, and I substitute as 1 squared 1 plus 8 squared 64 plus 2 times 1 times j plus 2 times 8 times f plus c is equal to 0. So I simplify that as 65 plus 2j plus 16f plus c is equal to 0. So 2j plus 16f plus c is equal to negative 65. That will become my equation 3. Okay, so I'm going to now solve my 3 equations simultaneously. So I'm going to add equation 1 and equation 2. So looking at equation 1, negative 10g, if I'm adding it to 6g, I'll get negative 4g. Then, looking at the f component, I have 4f and I'm adding it to 8f. That will give me plus 12f. But the c is going to be c minus c, so the c components will go. Negative 29 plus 25, that will be equal to negative 4. So I can simplify that as j, negative j plus 3f is equal to minus 1. and I'll label that as my equation 4. I'm also going to add equation 3 to equation 2. And so when I look at equation 3 and equation 2, it's going to be 2g plus 6g. That will be 8g. And then I have 8f plus 16f. That will give me 24f. Then c minus c will go away. And then 65, negative 65 plus 25 will give me negative 40. So if I divide through by 8, I'll get g plus 3f is equal to negative 5. And that will be my equation 5. Now, taking equation 4 and equation 5, I'm going to add them. So I'm adding equation 4 to equation 5. So I have g and negative g, so the g components will go away. 3f plus 3f will give me 6f equal to negative 1 plus negative 5. That will give me negative 6. That means that my f will be negative 1. Okay, now I'm going to substitute f into equation 5. So I have g plus 3 times negative 1 is equal to negative 5. So I have g minus 3 is equal to minus 5. Then g will be equal to minus 2. So g is negative 2, and then f is negative 1. Now I'm going to substitute these two values into equation 1. So I have negative 10 into bracket negative 2 plus 4 into bracket negative 1 plus c is equal to negative 29. So I have positive 20 minus 4 plus c is equal to negative 29. Here it becomes 16. So c will be equal to negative 29 minus 16. That will be negative 45. Now if I substitute the three values into the equation, the general equation, the equation of the given circle will be s squared plus y squared plus 2 times negative 2x plus 2 times negative 1y minus 45 is equal to 0. So the final answer will be s squared plus y squared minus 4x minus 2y minus 45 is equal to 0. That is the equation of the circle as required. Now we are going to use another method to solve the same question. So in this method, we are going to find the perpendicular bisectors and then use them to determine the center, and then with the center and any other points, we can continue to find the equation of a circle. So let's take the side AB. Then taking the side AB, we will have our midpoint as -5 plus -3, which is -8, divided by 2. That will give us -4. And then 2 plus -4, that will give us -2. Divided by 2 will give us -1. So that's our midpoint. Then the gradient, m, that is change in y divided by change in x. So if you take -4 and we subtract 2 from it, that will give us -4 minus 2 divided by -3 plus 5, which is -6 over 2, and that will be -3. So the gradient of the line joining the point AB is -3. And the gradient of a line perpendicular to line AB will have the gradient 1 over m, which in this case will become +1/3. And the perpendicular bisector will pass through the midpoint and has the gradient 1/3. So the equation of the perpendicular bisector will become y plus 1 is equal to 1/3 times x plus 4. And so that will give us 3y plus 3 is equal to x plus 4. So we have 3y here minus x is equal to 1. And that we will label it as our equation 1. Then we take the side AC. So we also find the midpoint of AC as -5 plus 1. That will be -4. When we divide by 2, that will give us -2. And then we take 2 plus 8. That will give us 10. Divided by 2 will give us 5. So that's the midpoint. Then we also find the gradient. So the gradient will be 8 minus 2 divided by 1 minus -5, which becomes 1 plus 5. This will give us 6/6, which is equal to 1. A line that is perpendicular to the line AC will have the gradient 1/m, which will be the negative inverse of +1. That will be -1. Okay, and the equation of the line will become y minus 5 is equal to -1 times x plus 2. So when we simplify, we get y minus 5 is equal to minus x minus 2, which gives y plus x is equal to +3. And we will label that as our equation 2. Now we take the equation 1 and equation 2 and solve them simultaneously. So equation 1, I'm adding it to equation 2. So when I take the y component, I'll have 3y plus y, which gives me 4y. Then when I take the x component, I'll have x minus x. So the x component will go away. And then this will be equal to 1 plus 3, which is 4. So my y will be equal to 1. Now with the y value obtained, I can substitute y into equation 2 to get 1 plus x is equal to 3. So my x will be equal to 2. Therefore, the center of the circle will be the point 2, 1. Now, with the center of the circle 2, 1 and any other point on the circle, I can substitute into the general formula. So I have my g to be equal to negative 2 and then my f to be equal to negative 1. So s squared plus y squared plus 2gx plus 2fy plus c is equal to 0. Now my substitution of the center, I'll have s squared plus y squared plus, so x is 2. When I substitute, I'll get 4g. Sorry, I'll get 4x. And then y is 1 when I substitute f for f. So that one, when I substitute, I'll get 2y plus c is equal to 0. Now here, I can choose any of the points given because they are on the circle, they satisfy the equation of the circle. And so when I substitute the point 1, 8, I'll get 1 squared to be 1 plus 8 squared to be 64 plus 4 times 1, which is 4, plus 2 times 8, which is 16, plus c is equal to 0. So when I do the addition, now I substitute into the general formula s squared plus y squared plus 2gx plus 2fy plus c is equal to 0. So I have s squared plus y squared plus 2. So now my g is negative, so 2 times negative 2 will become negative 4x, and then 2 times negative 1 will become negative 2y plus c is equal to 0. Now I need to find the value of c. So I take any point that satisfies the equation, and that is any of the 3 points given. So I'll take the point 1, 8. And when I put 1 squared, I'll get 1. When I square 8, I'll get 64. So here, negative 4 times 1 will be negative 4. Negative 2 times 8 will be negative 16 plus c is equal to 0. Now, 65 minus 20 will be 45. So 45 plus c is equal to 0. That means c is equal to negative 45. Now, substituting these into the equation, I'll get my equation required to be s squared plus y squared minus 4x minus 2y minus 45 is equal to 0. And that is it. And it is the same answer we got when we used the other method. Equation of a circle when ends of diameter are given. Okay, so when we are given an equation like this, and then there is a diameter like this given, and then we happen to get ends the end point of the diameter given as, let's say, x1, y1, and then another one, x2, y2. From circle theory, we know that when the ends of a diameter subtend an angle at the circumference, that angle will be 90 degrees. So if we subtend an angle at the circumference, that angle will be 90 degrees. So let's assume that the point where the two lines meet will be another point xy. Now with this, we know that the line, if here is A, B, C, we know the line AB is perpendicular to the line BC. And so when we find the gradient of AB and then we find the gradient of BC and we multiply, we are expected to get an answer which is -1. And that is a way of finding the equation of a circle. Another way is that when the diameter is given, we know that half of the diameter is the center. And so when we find the midpoint of the ends of the diameter given, that will give us the center. And with the center and any one of the given points, we can also determine the equation of a circle. Okay. Example. Find the equation of a circle drawn on diameter PQ, where P is 8, 4 and Q is 2, 2. Okay, so our solution. Now we have to assume there is another point on the circumference where the ends of the diameter will subtend an angle at 90 degrees. So that point, let's label it as R, and then its coordinates be x, y. Now, if we find the gradient of PR, we will get y minus 4 divided by x minus 8. And when we find the gradient of QR, we will have y minus 2 divided by x minus 2. Now, because these two lines are perpendicular, when we multiply their gradients, we should get -1. So we have y minus 4 multiplying y minus 2 divided by x minus 8 multiplying x minus 2. And this should give us -1. So I can rewrite it as y minus 4, y minus 2, x minus 8, x minus 2 plus 1 is equal to 0. And now I'm going to multiply through by the LCM. That will give me y minus 4, y minus 2 plus s minus 8 x minus 2 equals to 0. Now I will open the bracket and simplify. So y times y is y squared y times negative 2 is minus 2y. Negative 4 times y is minus 4y. Negative 2 times negative 4 will be plus 8. Now x times x is x squared. S times negative 2 minus 2x. 8 times negative 8 times x will be minus 8x. And then negative 8 times negative 2 will be positive 16 and is equal to 0. So now I will simplify and group them. So I will simplify y squared minus 6y plus s squared minus 10x. 8 plus 16 will be 24 plus 24 equals 0. And I will rearrange them as s squared plus y squared minus 10x minus 6y plus 24 is equal to 0 as the equation of the line of the circle I seek to find. Then the other method, the second method using the same point, is to find the midpoint of PQ. So midpoint of PQ, that will be 8 plus 2 divided by 2, and then 4 plus 2 also divided by 2. So the midpoint will be 5, 3. Now I have the midpoint and I have any point, 2 points on the circumference. So I can take the midpoint, which happens to be the center. So let me now call it center. So the center and any point on the circumference. You remember how we find the equation when the center and a point on the circumference are given. So that one, we are going to find our radius. So the radius is going to be r squared here equals change in x squared plus change in y squared. So if I take the point P, then I'll get 8 minus 5 squared plus 4 minus 3 squared. And that will be 3 squared, which is 9, plus 1 squared, which is 1. And so my r squared is 10. Okay. Now I have the center, so I can easily find x minus a. So the center is going to be like this. A is 5, so x minus 5 squared plus y minus 3 squared is equal to r squared, which is 10. So when I simplify, I'll get s squared minus 10x plus 25. And then I'm adding this to y squared minus 6y. Okay, let me rewrite it and then make efficient use of the space. So I have s squared minus 10x plus 25. Then I'm adding it to y squared minus 6y plus 9 is equal to 10. And that will be s squared plus y squared minus 10x minus 6y. So 25 plus 9, that will be 34. Then minus 10 will be 24 equals to 0. So when you look at this equation and then the previous one, you see that we get the same answers. Okay. Another example. Find the equation of a circle drawn on diameter AB where A is negative 2, 6 and B is 10, negative 10. Okay, so we also assume a third point. That is the point where we subtend an angle 90 degrees from the ends of the diameter. So if we label that as C, then our C is xy. So the gradient of AC will be y minus 6 divided by x plus 2. And the gradient of BC will be y plus 10 divided by x minus 10. Now if I multiply the two, I should get negative 1. So y minus 6, y plus 10 divided by x plus 2, x minus 10 should get negative 1. Okay, so this can be rewritten y minus 6, y plus 10, x minus 2, x plus 2, x minus 10 plus 1 equals 0. And so I'll have y minus 6, y plus 10 plus x plus 2, x minus 10. And this is equal to 0. So y times y will be y squared. Y negative 6 times y will be minus 6y. Then negative 6 times okay, so y times y is y squared. Y times y is y squared. Y times 10 is plus 10y. Negative 6 times y will be minus 6y. Negative 6 times 10 will be minus 60. X times x will give us x squared. X times negative 10 will be minus 10x. 2 times x will be plus 2x. And then 2 times negative 10 will be minus 20 is equal to 0. So I'll simplify y squared plus 4y, then s squared minus 8x, 60 and 20 will be minus 80 and it's equal to 0. So I rearrange as s squared plus y squared minus 8x plus 4y minus 80 is equal to 0. So that is the equation of the circle as required. Then we're going to apply the second method. So in the second method, we find a midpoint, which happens to be the center. So the center of the circle will be negative 2 plus 10, and that is positive 8. divided by 2. And then 6 minus 10, which is negative 4, also divided by 2. And at the center will be 4, negative 2. With the center and any of the points on the circumference, we can determine our radius. So the radius squared will be given as 10 minus 4 squared plus minus 10 minus negative 2, which is plus 2, also squared. That will give me 6 squared, which is 36, plus negative 8 squared, which is 64. That means my r squared is 100. With my r squared obtained and any of the points and the center known, I'll have my equation as x minus 4 squared plus y minus negative 2, which becomes y plus 2 squared, is equal to r squared, which is 100. So I open the bracket and get s squared minus 8x plus 16 plus y squared plus 4y plus 4 equals 100. That means I'll get s squared minus 8x plus 4y, sorry, s squared plus y squared minus 8x plus 4y. 16 plus 4 will be 20, so 20 minus 100 will be minus 80, which is equal to 0. And so that becomes the equation. Now when you check, you see that the two methods that have been used have all produced the same answer.